Say question. We have been given language L, that is a union of these two languages. Let us call them L1 and L2. So now for this language L, there have been given three statements, and from them we need to determine which of them is or are true. So let us first analyze what kind of language is this L. So for that we need to check out these L1 and L2 because we are having a union of two languages. So first looking at L1, which is simply a raised to n for all values of n greater than or equal to 0. So as we can see, this is simply a regular language because it will contain all the strings starting from null string to any number of a's. So this can simply be represented using a regular expression, that is a star, which means this L1 is a regular language. And then looking at L2, which is a raised to n, b raised to n for n greater than or equal to 0. So for this, we are having equal number of a's and b's. So looking at this, we can directly say that it is a DCFL because this is the kind of languages that are accepted by the DCFL language. And why deterministic context free? There is determinism because we cannot see any ambiguity in it. There are simply equal number of a's and b's, so there is no ambiguous decision to be made whether or not we have reached the midpoint kind of thing. So this L2 becomes a deterministic context-free language. And our language L, which is a union of L1 and L2, so it is a union of regular language and DCFL language. And we know that a union of regular language with DCFL language also results into a deterministic context-free language itself, which means our language L is also a DCFL. So now based upon this, let us analyze the statements. The first one is saying that L is a deterministic context free. That is what we have just derived. So it is true. Then the next one, L is context free but not deterministic context free. This is incorrect because L will definitely be a deterministic context free itself. Then the third one, L is not LL of K for any K. Now what do we mean by this LL of K over here? We have seen such type of languages. Here this K is a look ahead. So for any value of K, L can never be a LL of K. That is what it is saying. So let us analyze this statement. As we can see, L is consisting of strings of kind A star due to this L1, and it is consisting of strings of this type A raised to n, B raised to n for n greater than or equal to 0. So there are these two types of strings in our language L, and this is the reason what causes it to become non-deterministic. For example, when we encounter a string starting with two A's, then we cannot determine just looking at these two characters whether that string would be of the type A star or it will be of the type A raised to n, B raised to n. Which means just looking at two characters, you do not know what is there ahead of it. It is possible that this string is coming from language L1 if it is of this particular type, or it is also possible that it is coming from L2 and this is the midpoint, and after that B's will start. So it is of the type A raised to n, B raised to n, which means here we have considered K equal to 2, which means the look ahead of 2. So if we have some finite look ahead, we can still have some point in the future. After that, we cannot decide if it is coming from L1 or L2. So this is the cause of non-determinism in this language. So let us have a look at the statement. If we increase K, which means however large we make our look ahead, there will always be strings. There can still be the strings having more number of A's than the look ahead, which means this when our K was 2, then this was our point of ambiguity. If we increase K to, let us say, millions, then also we can put one more A in it, and then after that there will be a point of ambiguity at which we will not know if it is coming from L1 or if it is coming from L2. So it will always be impossible to decide however large we make our look ahead. So this is the cause of non-determinism in this particular language, and that is what is making it not a suitable candidate for becoming LL of K for any value of K. And that is the reason why the statement third is also true. There is no value of k for which the language becomes LL of k, which means we are able to determine what type of language it is actually there. If we have two A's, then we must be able to for sure determine if it is coming from L1 or L2, or what will be the next character after that. That is what the job of a lookahead is. So that is not the case with our language L, and hence statements 1 and 3 would be true for that. And hence we'll be going with this third option.